Japanese industry and companies have a lot of challenge in adopting DX and AI.
Yeah, in the last decade, represent a breaking through period in the AI world.
InfoDeliverスペシャル対談企画。創業時からプロジェクトを共に進めてきた AI、コンピューターサイエンスのスペシャリストを招いて、アメリカ、中国の最新 AI 技術の紹介、および日本の産業が抱える課題について熱い議論を交わしました。皆様、ぜひご視聴ください。
Thank you for joining us today, Dr. Cheng, Professor Wang, and I, Sunri, would like to hold a talk session on AI assessment solutions. At InfoDeliver, we have a long history of AI-related research and development. Our goal is to promote the solution of corporate issues in Japan and utilizing our knowledge and advanced technologies from US and China. We hope this talk session will help in that goal. As an outline of this talk session, we'd like to introduce the latest AI technology trends in the US and China, and clarify the industry issue in Japan. For this session, we invited Dr. Cheng and Professor Wang. Both had a long-standing relationship with our company. Now let me introduce them. Dr. Cheng, could you give us a self-introduction as well as your past research and publications?
Yeah, sure. Thank you very much for your kind introductions. Yeah. Not to see for a while. Yeah, it's my pleasure to meet you here to exchange our thoughts and about our common interest. So my research activities in my early years related to genetic algorithm is one of 5 drivers of machine learning. As you said, I co-authored several books on the topic how to solve the optimization problem with genetic algorithm. Some of the books still used as a textbook in the universities worldwide. Since 2010, I have put a lot of effort on another area, is GPU computing. GPU is invented by NVIDIA in 1999. It has revolutionized the parallel computing world. Especially GPU computing is one of the decisive factors to foster the deep learning booming again in last decade. Deep learning has become a hot topic for industry and science. It affects almost all industries related to machine learning and AI world. Most of open source library of deep learning has been accelerated by GPU computing. In 2014, I wrote a book about GPU programming. It's also published by RunweiCheng. The book has been ranking tops among the best parallel computing books of all time, many years. In 2019, I wrote a survey paper on how to accelerate genetic algorithm with GPU computing, published in the Computer and Industrial Engineering Journal. This paper is highly cited one. by researchers worldwide. My recent research interesting focus on applying the deep learning to solve geophysics problem in the oil and gas industry. Recently, I have been invited to write a book about deep learning. The target audience are those who knows less about computer science, who has less experience about programming, but who know well about his own discipline and research field, and who want to quickly dive into the AI world with TensorFlow and Keras. I'm working on my manuscript very hard each day. Hope I can finish this book by the fall of next year. That's all my brief introduction. Thank you.
Oh, thank you very much for your introduction, and we are looking forward to your new book. You are experienced researcher, and at the same time, you are a great writer. Now, Professor Wang would like you to introduce yourself and your research and so on. Could you?
Okay, thank you, Terry. My research focus in the recent decade is mainly on cyber-physical systems. So what is cyber-physical systems? It actually is a natural next step for AI, because one of the definite trend of AI development is that after AI is developed, AI will infiltrate every domain of expertise in the physical world. So for example, smart vehicles, smart transportations, right? Smart medicine, robotics, all of these physical world trades will be AI-ized in the future. So we will have the cyber part, the AI part, the computing part. We'll also have the physical part. So these kind of systems are called cyber-physical systems. So this is my focus. To be more specific, I'm focusing on the software engineering perspective of the cyber-physical systems, because this is the key challenge, a very unique and core challenge for cyber-physical systems. Why is that? To give an example, let's think about smart medicine, like surgical robots, for example. If we're going to develop a surgical robot, who is qualified to develop it? So for example, me, I'm an associate professor in computer science. I've been working in computer engineering, IT industry for like more than 20 years. So am I qualified to write this surgical robot? If I write the program to cut open your heart, do you dare to use it? Of course not, because you know, I know nothing about medicine, know nothing about surgery, right? So then is the surgeon qualified to write this program? Neither, because the surgeons, although they know how to do surgery, they know nothing about computer programming. So the programs may have bugs, so it will be very dangerous. So most of the cyber-physical systems, they involve multiple domain knowledge, and no one is fully qualified. Almost no one is fully qualified to know everything. But still, the cyber-physical systems are very often safety critical, mission critical. So how to guarantee the safety of it? So it's a very big software engineering challenge. So in my recent years, I'm mainly focusing on this problem. It has a very huge problem space. So when we talk about the application domain knowledge, we have medicine, we have transportation, we have robotics, control, smart vehicle, right? Different kinds of knowledge background. This is one dimension. Another dimension is software engineering practices. So when we talk about software engineering, there's always about requirement engineering, to know the requirements, to know the constraints. There's always about design, high-level design, detailed design. There is always about programming, and then testing and debugging and integration and maintenance. This is another dimension, the activities in software engineering. And the third dimension is various kind of technologies in computer science. So AI is definitely one of the major technologies that we are exploring to see whether they can help. So we have 3 dimensions: the domain knowledge, the software engineering activities, and the technology that we can exploit to solve the challenges in CPS, cyber physical systems, software engineering. So one of very interesting work that we have done recently is about exploring big data, about exploring AI technology to do oracle research. So what is oracle? Basically, when you are testing the programs, you need to know whether or not the output of the program is correct or not. So one of the trend in big data is that we're using big data to do debugging, to localize the possible suspicious lines or buggy lines in the software. So we need a tool to automatically judge whether or not the output of the program is correct or not. So this kind of tool is called oracle. So in robotics, there's in control CPS, there's the tradition is using human beings to do the oracle. But this is obviously not very ideal. So we are trying to use AI to address this problem. And we have made very good progresses on this. Yeah. So this is basically my job.
Thank you very much, Professor Wang. Thank you for your interesting example and your interesting introduction of your research. And I think your research is very important, especially to make the AI work properly for us in future. And we are working now. We are working with the proven professionals like Dr. Cheng and Professor Wang to address the challenges of the Japanese industry. As a side note, we'd like to briefly introduce some of the issues of the Japanese industry. Now we'd like to look at challenges facing the industry in Japan. Although DX and work style reforms has been talked about recently, the actual adoption of IT and automation of business operation in Japan has unfortunately lagged behind. Japan ranked last out of 12 countries in international survey on business automation, a joint study by US market research firm, Lawless Research and Service Now. Japan has the lowest rate of business automation and lags behind other countries in promoting digital transformation. For example, in the insurance industry, various application forms and operation related to the screening and assessment have company-specific rules. So manual operations are required, especially in the industry. Personalization for customers is required, and this leads to small lot and small quantity products tailored to individual users. As a trend towards developing a wide variety of products in small quantities becomes mainstream, the man hours required will increase as the total amount becomes smaller, but increase in the variety. Then there's a limit to how much can handled by manpower, and the cost performance goes down. Full automation of accident reception and assessment through DX is considered too difficult to adopt. To fully automate these operations, electronic data must be available at repair stores, car dealers, and medical institutions, and they are not affiliated with any specific insurance companies. In the damage insurance business as well, with a general house or company's factory or warehouse is damaged by natural disaster, insurance companies assessor or damage appraiser conduct an on-site survey. And based on the result of the damage assessment, photos of the site, and estimate of the amount of the damage, the general process is to calculate and scrutinize the insurance amount to be paid, and finally pay the insurance claim. The frequent occurrence of nature disaster in recent years and the shortage of appraisers have made it difficult for this task. Japanese industry and companies have a lot of challenge in adopting DX and AI. They are eager to evaluate, upgrade, and expand advanced technologies, but they also need to manage the product life of their legacy applications and quickly integrate them with needed automation solutions to improve efficiency and profitability. We believe many advanced technology can be used to solve the problems of Japanese industry. At first, we'd like Dr. Cheng to show AI technology trends in the US. Could you introduce some of to us?
Generative AI detects the underlying pattern related to the input and generates similar contents which look like a real one. Generative AI is one of the most promising advances in the world of AI in past decade.
And then in terms of robotics, robot installations in 5 major markets through 2017 to 2019, China, I think, is the most ambitious compared to other countries.